Hello everyone. Today we are in the chapter 4 of microprocessor 8085, which is the microprocessor architecture and memory interfacing. 8085 MPU, which is the term microprocessor unit, which is known as MPU, is similar to the term of central processing unit, which is CPU, used in the traditional computer. It can communicate with peripheral and the provide a timing signal, direct data flow, and perform the computing task as per specified by the instruction in the memory. Limitations: the lower order addresses bus of 8085 microprocessor is multiplexed with the time sharing with the data bus section. The bus needs to be demultiplexed. Another one, the appropriate control signal needs to be generated by the interfacing memory and the I/O devices of 8085. 8085 pin outputs. Here this device have 40 pins, requires a 5-volt signal for the power supply, and also can be operated with a 3 MHz signal pulse clock, and the second version of 8085 can be occupied by 5 MHz signal clock. All the signals can be classified into 6 groups. Here are address bus, data bus, control bus, or the status bus, then the power supply and the frequency signals, externally integrated signals or included interruptions, and lastly the serial input output ports. Address bus. In this section we have two segments. One is from A8 to A15, which is the highest one, and AD7 to AD0, which is the lowest one. It is also an unidirectional section. Here we have the signal line AD7 to AD0 are used for the dual purpose. Multiplex address and data buses. The signal line AD7 to AD0 are bidirectional. This serves as the dual purpose. They are used the lower order address bus as well as the data bus. The control and status signals. The control and status signals are the read-write section, and the status signals are input output and memory sections. In this we have ALE, which is known as the address latch enable. This is a positive going pulse which is generated every time by 8085 begins with an operation. It indicates that bit on AD7 to AD0 are the address bits. The signal is used primarily latched in lower order address for multiplexing the bus and generates a separate set of 8-bit address lines, which is from A7 to A0. The read signal is to read the section, and this one is the active low section, and write signal is for writing on the memory or the I/O devices, which is also an active low section. I/O-M means I/O is for the input output section and M is for the memory location. Here, if the condition is normal, then the I/O will work, which is read and write operation will be work on the input output section. And if the signal is active low, that reasons that times the memory section will be activated, because the memory section is active low because it has a bar on top of it. So if the signal is active low, then the read write will happen with the memory section. Here we have the S1 and S0. Those are known as the status or signal simulators. Here is the pin diagram of 8085. In this section, we have firstly the X1 and X2. Then X1 and X2, they got married and they raced out from the house. That means that X1 and X2 generates the reset out. That means they go out from the house and they took two babies that are SOD and SID on port number 4 and 5. Then they got into a trap which is number 6 port. Then comes the RST 7.5, 6.5 and 5.5. They interrupt means INTR on port number 10 and they attempt on INTA which is active low on port number 11. Then they also have their brothers and sisters which starts from AD0 to AD7 and port number is 19. Then they go to the ground section which is on port number 20. Then on port number 21 to port number 23, to port number 28 which is A8 to A15 are the siblings of AD0 and AD7. Then they got their lost S0 and then comes the ALE section. He needs to write and read which are on the 31 and 32 number position and they go to their sir which is S1 and they also want to read write on the input output section and also in the memory section which is on the 34 number port. Now they are ready to reset in because they already rest out from their house, so they need to reset in on the 36 number port. After that, at the time which denotes at the clock out on the 37 number port, they go to home and they saw that there is a hold which is as HLDA on 38 number port, and after that a man comes with a gun and said hold on 39 number port. Then they got the VCC or the victory on the 40 number port. This is the easy sequence to remember the 40 ports of 8085. You can have a snap of this diagram. Now, here the power supply and the clock's frequency section. Here VCC is the power supply which is 5 volt, VSS is the ground section. Here X1 and X2 is the RC and LC network connected with those 2 points. The frequency of initial divided 2 by 2. Therefore, the operates the system by 3 MHz should have the frequency of 6 MHz. Now clock out is the signal can be used in the system clock. Serial input and serial output is the serial input data which is SID and SOD is the serial output data. This diagram is very important in your examination question. This is the machine cycle status or the control signals. (8085) interrupts and external signals. Here external signals are reset in. That means when the signal on the pin goes low, the program counter is set to the 0 and buses are tri-stated and MPU is reset. Then the reset out means it goes on its general works. Here are the description of another pins. INTR is the input, INTA is the output section. Trap is an input section, hold is also an input section. Hold acknowledgement and ready. In section hold acknowledgement is the output and ready is the input signal. Here is the data flow from memory to MPU. By this diagram, we have already covered this one in our previous chapter, so we are skipping this now. This one is the timing transfer of bytes in memory of MPU. In this section, we can easily say that here we have times which are divided into 4 sections: T1, T2, T3 and T4, and clocks are going like this. In every time we have one low and one high section. Here from A8 to A15 is used for the higher order memory address, which is 20H, and the lower order is the 05H, which is denoted by A0, AD0 to AD7. Here the opcode is 4FH, or which is the opcode, and this one T4 here is the unspecified section for higher order. Here ALE is the arithmetical logical unit, which is first active high, then goes active low. Here we have the low signal, that means it works on the memory section because memory is the active low section. And in read section, when the signal is low, then the read will start. So here we have the low signal from this point to this point. That means the opcode will be fetched or read by the memory on this point to this point, because the read section is active from this point to this point on the memory section, because memory is already active low. This diagram is initiated for these characteristics of sections. In here, first of all, the address is going on the memory section, then control signal is going on the memory section and put the data 4F on the data bus, and it carries the data to the internal bus, and then the instruction is decoded and then executed. This is the diagram of this function. Now moving to the next. In this section we have memory location 2000 and 2001. By that we have the machine code for 2000 is 3E hexadecimal and 2001 which is 32 hexadecimal. In this instruction we can write MVI, which is move to the immediate, because 2001 and 2000 is the immediate. So MVI A 32 means to load the byte 32 to the accumulator section, which is denoted as the A section. This is another diagram. This is the homework for you. You can easily understand that it is the read function. When the read function occurs, when the signal is active low, so this section reads this opcode and this section reads this opcode. The lower order sections are also denoted in AD0 to AD7 sections in those types, and ADA and A8 and A15 is for the higher order one. In this section 20 and 00, those are divided by 2000, and 20 and 01 which is divided by 2001. Clock is always same, and here we have divided it into first one in the 4 part, which is the fetching part, and second one is the reading part, which is divided into 3 time cycles. For each dividation we have one ALE signal, So that's why it is active high first, then low, and this is the new section. That's why it is again active high and then again goes low. This one is the simple diagram of typical memory chip, which is the read-write stack memory. You can have a snap of this one. This one is the input buffer, this is the initial decoder, and this is the output buffer. This is the diagram of EPROM that we have discussed in our previous lectures. You can have a snap of this one. EPROM is known as the erasable programming ROM or read-only memory. Now we are in the memory interfacing section. Here we have be able to select the chip, then identify the register, then enable the appropriate buffers. Those are the memory interfacing instructions. This is the timing diagram of memory read cycle. By this diagram, you can see that here we have three timing cycles. This one is the clock section. This one, A0 to A15, is the memory address, and AD is the data section. Here, the IO and memory section, here the signal is low, that means it is the memory section, and read is do its work when the signal is low, and it's the reading from the memory, so it is also an active low signal. So that's why the read, when the read memory and the IO memory is low, then it can only read the data from the memory. This is the timing diagram of memory writing cycle. So here we can see that this one is for memory address, this is the clock, and this is the time cycles. Here this one is for the data, and here you can see that the signal is low, that means the memory is activated. And here we have write signal instead of read. Write is also an active low signal, that's why when it is active low, then the write signal is activated, and this is writing on the memory. So the MEMW, which is the memory write, when it is low, then the memory write will be activated and doing its job. This is the diagram of address decoder. This is not so much important, but you can have a snap of this one or go through that. This is the diagram of an interfacing circuit. Here we have the EPROM, which one is the erasable programmable ROM. Here we have the memory and the read devices, which generates the memory read signal, and by this 3 to 8 decoder we generate a selection unit. By the selection unit, it selects, and the data is going from A0 to A11. This one is the address line, A0 to A11, and D0 to D7 is the data line, which is for the data bus. That's for today. Thank you. Hope you guys enjoyed this series of 8085. Thank you.